During class, we considered the cart string hanger problem that we made predictions for in our earlier class. More specifically, we took a closer look as to what the force diagrams really would look like for the cart only, for the hanger only, and for the cart string and hanger combined. We found out that the only thing that would make our system accelerate is that gravity pulling on the hanger. So the gravity or weight of the hanger is the net force, and it is what caused the system to accelerate. Then kids ran through a lab. They put an increased number of masses on the hanger to increase the net force acting on the system, and then they recorded accelerations. This data table that you have on your sheet is what people will be filling out on the sheets. We did ask kids to make a hypothesis. If we increase the net force acting on the system without changing the mass of the system, then the acceleration would it increase or decrease or remain constant? What are we going to change? The net force by changing the mass of the hanger. What are we going to measure after each trial? We're going to find the acceleration by looking at the slope of a velocity versus time graph that we'll hook up to a computer that is synced up to the PhotoGate and Smart Pulley. What are we going to keep constant? The mass of the system is going to remain constant because all the masses we add to the hanger are originally going to be on the cart. So those masses will either be on the cart and the hanger the whole time, but if they're on the hanger, it'll increase the net force without changing the mass. We'll be recording the mass of the system here, including in the video. You can put the mass of the system in there. You'll need to convert that into kilograms. Remember, there's 1,000 grams in a kilogram. And let's get on to how to fill out that data table. So when you have your data table, there's a place in here for you to put your name, the name of your lab partners, today's date, and then also you're going to want to record the mass of your cart string and hanger. Notice that we've already put the mass of the hanger in here. Because the mass of the hanger is in grams, we need to have it so that it's set up in kilograms. And we know there's 1,000 grams in a kilogram. So what we're going to do is we're going to use the equal button and say, I want you to take the mass of the hanger and we're going to divide it by 1,000 grams per kilogram and then hit enter. And I do want to apply this all the way down. And so those are going to be the mass in kilograms. Next up, I want to know what the net force acting on my system is. Well, we know the net force is the weight of the hanger. Just like we've been calculating in class, we're going to take the mass and multiply it by 9.81 newtons per kilogram. So 9.81 times, and then I'm going to click on the mass of the hanger in this top column. And I'll hit enter. It'll ask, do we want to do that for all of them? And the answer is yes. So now we have all of our net forces as well. You'll need to watch the video to find the corresponding accelerations. The accelerations I'm about to type in here are false. They're not correct accelerations, so you should not use them. But I'll just put in here a half, 1.5 meters per second, 2.5 meters per second squared, and so forth. So how do you go about making an acceleration versus net force graph? Well, we have found from previous workings with sheet that the first column we highlight ends up on the x-axis and the second column we highlight ends up on the y-axis. So if with the column we have, this should show up on the x and this should show up on the y. And we'll go ahead and insert. Even though we want a graph, they want us to choose the word chart. And we'll do that, and I'm going to go ahead and squish this down. Well, I'll keep it big so we can see it. We have a title, acceleration versus net force. We have acceleration with the units here, and we have net force with the units down here. If for some reason you don't have dots like this, you've got bar graphs or something, please choose the scatter chart. Next, from setup, and by the way, if this screen doesn't pop up, if you just double click on the graph, the chart editor will show up. I can click on there again. Once we've got that, we want to go to Customize. Within this, find the open link that says Series. We're going to open up that, and we're going to scroll down. Earlier in the year, we would draw a best fit line with a ruler before we calculated slope. Now we can just click Trend Line, and then go down a few more where it says Label, and we're going to choose Use an Equation. And just like in our previous labs, it'll then give us a slope of our graph. Now, one thing that I'm noticing about my graph is that it's not zeroed out at 1, and I'd prefer that it be zeroed out at 1. First, I'm going to grab this and get it out of the way of the other stuff. So I'll put it down here below everything. And then notice that the starting net force is not 0. So I'm going to click on the graph again and see if we can fix that. So go to Customize, and let's go to the horizontal axis and put in a minimum value of 0. And now, are we zeroed out down here? It looks like we're zeroed out. And it looks like with the values we've picked, maybe the y-intercept didn't turn out to be exactly 0. I think that when you guys do that with the real data, your y-intercepts will be pretty close to 0. Anyway, so that's what you should have. You should have a title, label, and units for each of the axes, and you should have gone through and used the chart editor and series and used the label to find the slope of the graph. Again, this slope should not be in line with what your slope is, but we'll take a look at those. Remember, all the values that I put in that column, I put those in red, and those would be false data. You need to put in your own values there. I hope that helps.